Welcome to Automotive Appreciation Part 4. In this section we'll cover basic electricity, multimeters, magnetism, DC and AC current, relays, batteries, alternators and starters. We'll use an analogy with a water circuit to explain the operation of an electric circuit. The water pressure due to the height of the tank is similar to the potential difference or voltage provided by the battery. The valve is similar to the switch and the wheel is similar to the lamp, while the flow of water can be compared to the flow of current. The valve allows the water to flow, which turns the wheel. The switch provides a continuous path for the current to flow, and the resistance of the lamp produces heat and light. When the switch is opened, the circuit is broken and the current ceases to flow. The potential difference or voltage is measured in volts and has the symbol V. Current is measured in amps and has the symbol I. Resistance is measured in ohms and has the ohm symbol. Electric calculations are based on Ohm's law, which states that voltage equals current multiplied by resistance, or I equal to V over R, or R equals to V over I. When resistors are connected in series, we add the values to get total resistance. With resistors in parallel, we use this formula. A multimeter allows current, voltage and resistance to be measured with one instrument. When voltage is selected, we measure 5 volts and 15 volts. For the purpose of the demo, we assume the conductor has no insulation. The voltage at this point is reduced to 6 volts due to the voltage dropped across the resistor and further reduced to 2 volts at this point. To measure resistance, ohms is selected and the resistors are disconnected from the circuit. To measure current, one of the measuring leads must be changed to the current measuring port and amps is also selected. To measure current, we must break into the circuit and allow the current to flow through the multimeter. There is 3 amps at the top of the circuit, which divides into 2 amps and 1 amp. The conductor of a cable is used to carry electrical current. It has low resistance and usually is made from copper. The insulation has high resistance and is usually made from plastic or PVC. There is a close link between electricity and magnetism. Electricity can be used to make a magnet, or a magnet can be used to make electricity. When the magnetic field moves past the conductor, electricity is induced. The current flow from a battery is DC, direct current. If we look at the voltage, it's constant. If we look at the voltage waveform from a generator, it's changing from positive to negative. If this alternating voltage waveform is applied to a circuit, it will result in an alternating current flow. A relay also depends on magnetism to operate. It has 3 contacts. The centre is common, the one on the right normally closed and the one on the left is normally open. When a voltage is applied to the coil, it attracts the armature and the centre contact changes over. A relay allows a low power circuit to operate a high power circuit. For example, the rear window defogger in a car. Fuses protect an electric circuit from excessive current, overload and heating. It consists of a thin section of conductor, which in this case is rated for 5 amps. If the fuse current rating is exceeded, it will overheat, burn and isolate the circuit. The main parts of automotive electrics are the battery, alternator, starter motor and consumers. The battery provides energy storage for starting the engine via the starter motor. When the engine is running, the alternator supplies energy to the electrical consumers and also recharges the battery ready for the next startup. Normally the return wires are dispensed with and instead the chassis of the car is used for the return circuit. The battery provides energy storage for starting the engine rotating. At standstill, the voltage is rated at approximately 12.5 volts, and for this engine it drops to 10 volts when cranking and rises to 14 volts when the engine is running and the battery is charging. The alternator is used to supply energy when the engine is running and is belt-driven from the crankshaft. It consists of a stationary winding called the stator and a rotating magnet. When the magnet rotates, the magnetic field induces a voltage in the stationary conductors. Instead of using a permanent magnet, an electromagnet is used. By varying the amount of current in the rotor winding, it's possible to adjust the output voltage. Slide rings and brushes are employed to allow the current enter the electromagnet, and the flow of DC current is controlled by the regulator. As the alternator produces an AC voltage waveform, it must be rectified and converted to DC using a rectifier. The rectifier consists of diodes which act like one-wave valves and only allow current to flow in one direction. If the speed of the alternator increases, so too will the output voltage. To reduce the output voltage, we reduce the excitation current to the rotor. This reduces the alternator voltage and the output voltage from the rectifier. Here we show the schematic of an alternator. The rotor induces a voltage in the stationary winding. When the top of the stator is positive, current flows in this direction into the top of the battery, and when the bottom is positive, it again flows in this direction. At all times, flow is in the same direction. Most alternators will have 3 phases in the stator. This results in a smoother DC output waveform for the battery. The starter motor is used to crank the engine when the key is turned. It consists of a stationary part called the field windings and the rotating motor. When current is fed through the coils, the electromagnets create a magnetic field. This current also passes through brushes and the commutator to the rotor, creating a separate magnetic field. Here we see the magnetic field from north to south due to the stationary winding. The current through the rotating winding sets up a separate magnetic field. The interaction of the 2 magnetic fields causes the rotor to turn. When the key is turned, the solenoid or relay is energized, the plunger moves forward and engages the pinion with the flywheel. At the end of its travel, it closes the main contacts for the starter. High current passes through the heavy cables and the motor rotates and cranks the engine. When the key is released, the solenoid moves back, stops the motor and disengages the pinion. Note, the flywheel remains rotating. Recent developments with starters include the use of permanent magnets and a reduction gearbox. This allows the starter to spin at a higher speed and results in a lighter starter. Some modern units combine the starter and alternator in one unit, which is controlled by the ECU, allowing the option of energy recovery during braking. We hope you learned from Automotive Appreciation.